All right. So today we're looking at coordinate proofs. You haven't had enough proofs already in your life. So a coordinate proof, it's placing a geometric figure into a coordinate plane using the distance formula, midpoint formula, and postulates and theorems to prove statements about the figure. This isn't quite as in-depth a process as the proofs we've done, the two-column proofs in the past. It's more mathematical, which most people like. All right, so first thing says place a 3-unit by 5-unit rectangle in a coordinate plane. Right. A fairly simple process. So 3-unit by 5-unit doesn't give us any direction as to where to put it. So we're going to go to the right 3 and up 5. Try to draw a line straight. Not very good at that. Right, so 3-unit by 5-unit anywhere in here. Or I could have done it this way. Because the math that if we were going to do some kind of coordinate proof math operation with it, it really doesn't matter what direction or where we put it, as long as the dimensions of it are the same. Right, so then it says a right triangle has legs of 6 and 8. Place the triangle in a coordinate plane, label the vertices, and find the length of the hypotenuse. So, like I said, it really doesn't matter where we put it as long as we follow the directions as about the figure. So legs of 6 and 8. So if I start at the origin and go over 6 and up to 8, we got a right triangle. One thing about using the origin as one of your points is we're about to find the length of the hypotenuse. So finding the length of anything on a coordinate plane usually means we're going to use the distance formula. So if you use the origin, you've got zeros in there, which makes the distance formula a whole lot easier. So because the origin we know is the point 0, 0. So that's one end of the hypotenuse. And the other end of the hypotenuse is going to be 0.68. Right, so to label the vertices, so A, B, C. And then we're going to find the length of the hypotenuse. That takes us back to the distance formula, which is the square root of x of 2 minus x1 squared plus y sub 2 minus y sub 1 squared. And so based on the points that we've got, 0, 0, and 6, 8. So for the x's, it'll be 6 minus 0 squared plus the y's, 8 minus 0 squared. So 6 minus 0 is just 6 squared. 8 minus 0 is 8 squared. So 6 squared is going to give us 36. 8 squared, 64. And 36 plus 64 would give us the square root of 100. And everybody knows the square root of 100 is 10. So that would be the length of our hypotenuse there, 10 units. Questions there? Anybody? And like I said, it didn't matter where you put the right triangle in the grid, just by using the origin as one of your endpoints made the math a little easier. But all right, so this one in the diagram, triangle ABO is congruent to triangle CBO. Find the coordinates of point B. And yes, I'm very aware that if you look at the picture, you can pretty much tell exactly what the coordinates of point B are. But in other problems like this, it may not be quite as simple to just look at the graph and write the point down. That intersection could be in between points. So you'd have to guess, is that a half? Is it a third? What is that? So we're going to approach this like we can't see where that point B is. And so it tells us that the ABO, so ABO, this top triangle, is congruent to CBO, the bottom triangle. Which, if the two triangles are congruent, then that tells us that all the corresponding parts of one triangle are going to be congruent to the corresponding parts of the other triangle. So AO would be congruent to CO. BO is shared, so it's corresponding, it's congruent to itself. And then AB and CB will be congruent to each other. So when we look at it this way, we should recognize that since AB and CB are congruent segments, that point B, for all practical matters, is the midpoint of segment AC. Right. So, like I said, if we couldn't tell what the exact coordinates were by looking at the graph, since B would be the perfect midpoint of AC, then we can use the midpoint formula. Everybody remembers the midpoint formula? X1 plus X2 divided by 2 gives you the X coordinate, and Y1 plus Y2 divided by 2 gives you the Y coordinate of that midpoint. So, point B, we're using coordinates of A and C, so 0, 10, and 10, 0. So for the X's, it's going to be 0 plus 10 divided by 2. And for the Y's, it's going to be 10 plus 0 divided by 2. Which will give us 10 over 2, 10 over 2, otherwise known as 0.55. Which is exactly where B looks like it is on the graph right there. But like I said, it could be not perfectly at an intersection where you can see exactly what it is. So if not, this is how you would figure it out. Questions there? Anybody? All right. All right, and then here, we want to find the coordinates of point P. And we're doing that based on the coordinates that we have for the other points that are in the picture. And it always throws people off when they look at these coordinates and they see letters instead of numbers. But what we have to keep in mind is this point P is on a horizontal line with point M, right? And so if they're on a horizontal line, then P and M both share what coordinate? What coordinate would be the same for both of those points? Well, if it's a horizontal line, then you're at the same point on the Y, right? 1, 2, 3, 4, 5, 6. Of course, we're not using a number there. They got a letter for the Y. Okay. So we know the Y coordinate is K, because P and M are on the same horizontal line, so they have the same Y coordinate. Likewise, P and N are on the same vertical line. And that vertical line has the exact same X coordinate. Wherever you are on that vertical line, the X coordinate's the same. And so the X coordinate for N is H. So that's what we're going to put down as the X coordinate for P. So that's all there is to that. But it throws people off every time because they see letters there instead of numbers. Right, so that finishes the notes, I believe.